Hello everyone. So if you see here, we have one scenario. Here we are going to configure the OSPF and we are going to check the router ID. As we discussed before, router ID, how they are going to select, same thing we are going to verify. What we discussed in our theory, we are going to verify that is correct or not. So if you see, we have the router R1 here and we have the router R2, we have the router R3. And here in between the R1 and R3 we are using 200.1.1.2 here, this interface, and this interface we are using 200.1.1.1, and in between the R1 and R2 we are using 192.168.1.1 and 192.168.1.2. and for the R1 we have the two loopback 0 we have, that is 1.1.1, and we have the loopback 1, we have the 2.2.2. Why we are using loopback? If you want, you can use this one physical interface and then we can connect to the switch and we can do, but I don't want to use that one. So instead of using that one, I will create the loopback. Instead of using the physical switch, I will use the loopback. And also physically, when we connect the cable, sometime maybe cable is having issues, sometimes someone remove the cable from the switch or from here, we will have the issue, our link will go down. If the router ID is this one and if this interface go down, then we will have the issue. So in the real scenario, in the production network, what we are doing, we are giving the router ID as a loopback only. We are creating the loopback to make the connectivity in the real scenario. Also in the BGP also, we are using the loopback only, because loopback is a logical interface. It will never go down, always it will be up. Until and unless the router is working, it never go down. If this router go down, then only loopback go down, else it will not go. Someone need to go inside the loopback and make shutdown physically, then only it will go. Means he need to type the shut inside the loopback, then only it will go, else it will not go. So for that purpose we will use the loopback. So now we will start the configuration. So what we will do here, let me take the notepad and we will do the configuration. In our previous class we done with the using the network command. In this one we are going to use the interface method. We have different method, we can use different method to configure the OSPF, because some guys are using some different method also. Let me show you. Just now what we discussed, OSPF 1 and network, and here after that we are using the network command here. Like example 192.168 1.1 1.0 and then 0.0.0.255. and then area 0. This is a one method, we area 0. This is a one method. This method is known as network command, enabling the OSPF by using the network command. If we configure the OSPF by using this command, we are calling enabling the OSPF by using network command. We have one more, that is interface method. In the production network, 95% or 99% we are using the interface method only. Most of the time we are using interface method only. We are not using this one. Sometime we use this one, but mostly we are using interface method. We are going to learn that how we can configure OSPF by using interface method in this lab also. And for lab purpose, we can configure another way also. Instead of writing this one, what we can write here, in this place we can write all are 0. Example, for lab purpose, not in the real scenario, 0.0.0.0 0.0.0.0. This way also we can configure OSPF. We are saying whatever will be the IP address, whatever will be the subnet mask, enable the OSPF. If you run this command, it will enable here also, it will enable here also, it will enable here also, it will enable here also. But in the, if anyone come here and if anyone connect any interface and assign the IP address, automatically that interface also involved in the OSPF. That is not recommended to do this way in the real scenario. Only for the lab purpose we can do this method. Okay, so we have another method also. What is another method? Instead of writing like this way, what we can do, we can do another method. Here what we will do, we will write here we will say all 0, and here we will write all 255 255.255.255.255. This is also another method. For lab purpose only we are using. Okay, real method is router OSPF 1, network ID, wildcard mask, area 0. For lab purpose we will keep this also 0, this also 0, or this all are 0 but this all are 255 4 times. This is also another method. for lab purpose we can use. With this one also OSPF will enable it in all the interface, whatever interface. If you write this command in this router, all this interface, example F0 by 1, F0 by 0, loop 0, loopback 0, loopback 1 will have the OSPF. If someone create loopback 2 also, automatically OSPF is going to enable in that interface also. And it is not recommended in the production network. We will not use this one, only for lab purpose. If anyone want to use, they can use this one. Okay, in some lab we are going to use also, no issue. So now we will see the industrial method which we are using in the real scenario in the production network. That is a interface method. So let me write the configuration here. First of all, I will give heading here OSPF router ID, OSPF router ID lab. Okay, so first we will do the configuration for the R1 configuration, enable config T host name R1, whatever name you want you can give, and then we will check how many interface we have. We have interface fast Ethernet 0 by 0. This one is a fast Ethernet 0 by 0. So we will give fast Ethernet 0 by 0 IP address 192.168.1.1, give space 255.255.255.0. This is basic, just assigning the IP address to that particular interface. Okay, this is the interface fast Ethernet 0 by 0. Now we need to do for fast Ethernet 1 by 0. I will copy the same thing, I will paste here, and I will change this interface name as 1 by 0. So this will be 1 by 0, and here IP will change, that will be 200.1.1.1. Okay, so this way we will assign the IP to this interface also. Now we will go for the other interface. I will copy the same thing and we will paste here. We need to create more two interface, that is a loopback 0, loopback 1. So I will write interface loopback 0. LO we can write, give space and write the number, what number you want to give. LO means loopback. This is the shortcut way, we will write loopback as LO. And then this is a 0. And IP what I am planning to give here, 1.1.1.1. So I will write here 1.1.1.1. Okay, and subnet mask, if we are considering the class A, and here we write one time extra I think. So let me delete this one. Okay, 4 time we have 255. Yeah, let me remove this one time, I think extra we wrote. Okay, here also we type extra, let me remove this also. Okay, so this is a class A, this is a class A, so I will give this way the subnet mask. Okay, this is a loopback 0, and then we need to create the loopback 1. So I will take this one also and we will keep here loopback 1. So this is a loopback 1 and we will give as a 2.2.2.2. This is a basic configuration, just we assign the IP address. We assign the IP address fast Ethernet 0 by 0, fast Ethernet 1 by 0, loopback 0, loopback 1. So this is just assigning the IP for the R1. Okay, let me check, someone write something. Yeah, I corrected, thank you. Yes, this one. Okay, so now we will write the OSPF configuration. So already we learned, whenever we want to configure, we will write router OSPF, and the process ID I am giving 1. Whatever you want you can give 2, you can give 3, no problem. Okay, it is a locally significant, you can give anything in any router. If you use example, if you give process ID here as a 1 and here as a 2 and here as a 3, no problem, it will work. But when we are doing the EIGRP, we need to write same number. If you give 1 here, here also be 1, here also be 1 in the EIGRP, but not in the OSPF. In OSPF it is a locally significant, so it will be available only router only, inside the router, not the outside other router. Anyhow, we will use same thing. So now I wrote router OSPF 1. Then we need to write the interface. We need to go inside that interface. Okay, so I will write interface. Which interface? Fast Ethernet 0 by 0. I have one interface, this one. I have another interface, this one. So let me copy and paste here. I have one more interface, this one, loopback 0. I have another interface, that is a loopback 1. So I have 4 interface. Total interface I have 4. In this router I have total 4 interface. Okay, so I need to configure the OSPF in the 4 interface. So this method which we are using now is interface method, activating OSPF by using interface method. So how we will activate means we need to go inside that interface and we need to write IP OSPF 1 area 0. Why I am writing 1 here? OSPF. Here I wrote wrong. OSPF. Okay. So what we are saying here, this one we will say router OSPF 1. After that, which interface you want to activate the OSPF, go inside that interface. How we will go? We need to write interface F0 by 0 means we are inside this interface F0 by 0. Then we need to write IP OSPF and the process ID. You need to remember whatever process ID we give here in the router OSPF here, that same process ID we need to write here. And then area, and whatever the area we are using, write that area here. Okay. So I will copy. This will be same for the all the interface. So I will paste here. How it is same? If anyone is having doubt, let me explain again what I am saying here. I am saying here we will go inside the interface. How we are configuring the OSPF? First we are writing router OSPF 1. This is a process ID. Then we are looking in which interface we need to activate the OSPF. We need to activate the OSPF to this interface and to this interface and this interface. So we need to go inside that interface. How we can go? We need to write interface fast Ethernet 0 by 0. So now we are inside this interface. We need to write, when we go inside that interface, after that we need to write IP OSPF and the process ID, whatever we use, same process ID should be here. That is a 1. Then area, and which area? Later we are going to do the lab in multi-area. In CCNA we don't have multi-area OSPF. In CCNP we have. So we are going to do like we will have area 1 here, area 2 here, somewhere area 0 we will have in the coming labs. Now we are using only area 0. So this one. First interface is finished. We activate the OSPF in this interface. Now we will go for the other interface. We need to go inside that interface. We go with this command inside that interface, and then we need to write the same thing. IP OSPF 1. This is a 1. That's why it is 1. And then area 0. And then we will go inside the loopback 0 and we will do same thing. IP OSPF. This is a process ID 1. So here also process ID 1. Then area 0. Later we will have maybe 0 here, 1 here, 2 here, maybe 3 here in the coming classes. But now all are in the same area. We are saying this all are in the same area. The area 0. This all are in area 0. Okay, so we enable here in the interface loopback 0. Now we need to enable in the loopback 1. So we will write interface loopback 1. Interface loopback 1. We go inside the loopback. Then we will write same thing, IP OSPF 1. This is 1 because here we use the 1. Process ID is 1. Then area 0. So this way we can enable the OSPF in this router. Okay. So now we will configure the OSPF for the other router. So this one is the configuration for the R1. Now let's do the configuration for the R2. So R2 is having the same configuration, but we have only one interface, so it will be much easier compared to the R1. Less configuration we will have, but anyhow I will copy the whole configuration of R1 and I will paste here, and we will modify the R1 configuration. So here this is a R2, this is also R2, and this interface fast Ethernet 0 by 0. So we will have here 0 by 0, and the IP address is 192.168.1.2. So this should be 2. And this one we don't have, this one we don't have, so we don't have this one also, so I will delete this one. Okay, and if you see here only one interface, so this is okay, no issue. And then if you see, I will delete this all. We don't have this all, we have only one interface. So with this command we enable the OSPF. We are saying router OSPF 1. Then we go inside this interface and we put the command IP OSPF 1 area 0. So OSPF will enable in this interface. That's all for the R2 configuration. So now I will divide this notepad. Then we will do for the R3. In R3 also what we have, we don't have any loopback here also. Only one thing we have here, that is fast Ethernet 0 by 1. So this is simple configuration. I will copy the R2 only and we will paste here, and then we will modify here. This is a R3, this is R3, this should be 200.1.1.2. so I will write here, this one is a 200.1.1.2. okay, that is a R3 pass Ethernet 0 by 0 200.1.1.2 subnet mask, and then we have router OSPF1 interface, this interface 0 by 0 IP OSPF1 area 0. okay, this is good. And if we see in the R1, we put this one, this interface F1 by 0, here R1. So now configuration is okay, everything is good. We can run this one, we can copy and paste. So let's start. I will go in the R1. okay, this is a R1 router R1, this one. So now we can copy paste directly, but I want to show you, that's why what I will do, let me paste from here to here till here to here, then I will show you about this configuration by typing. So I am copying and pasting here only the IP address only. okay, so this is the IP address, we paste only the IP address. And for the loopback, wherever we create loopback, no need to write no shut, automatically this port will go up. But as we copy paste from here, that's why this came. Even if you did not write for loopback interface no shut, no problem. It is not necessary you should write no shut for the loopback. Loopback is logical interface always up, so no need to write this one. If you see, we did not write, even I did not press enter, but this interface go up. This is a loopback 1. If you see, loopback 1 go up here already. okay, if you see, this is a loopback 1, already it is up, but I write here no shut, but I did not put, let me put now. Anyhow, a loopback interface, even if we did not write no shut, it will work, no issue. So now what we done, just we assign the IP address for the R1. If you want, I will show you, we will write show IP interface brief to check the interface status. So if you see here, this is a fast Ethernet 0 by 0, we have 192.168.1.1, this is up, and if you see, this one is a 192, this one fast Ethernet 1 by 0 is 200.1.1.1, and this is also showing up. But in the real scenario, you will not have up, because this is a simulator, that's why this port is showing up, because here this port is down. okay, this port is down, this port is down, and still we did not keep this port as a no shut. So how this port should come up? Administrative, it should be down, but it is showing here up, because this is a virtual lab, not a real lab. But no issue, we will configure now. okay, but in the real scenario, you will see here, for this interface administratively down here, not here, protocol is down here. Administratively means we manually write no shut, so this go up, but the other end is not connected, this one, then it will show you down, protocol is down. If we go inside this interface and if we write no shut, then it will go up. If we do in the packet tracer, it will be down, but here it is showing up. In EVNG GNS3, it is showing up even if it is down. So this is a small bug here, no issue. Anyhow, we configured the IP address, we have the IP address. Now we need to configure the OSPF by using the interface method. So what we told, we will write router OSPF1, then we need to go to the interface. So I will go inside the interface, fast Ethernet 0 by 0, then we will write IP OSPF1 area, which area we want to give, we can write that area 0. This is the first interface we enable here. Now we need to enable here, so we need to go there, that interface also, interface fast Ethernet 1 by 0, then we can write IP OSPF1 area 0, then interface loopback 0, and then we need to write same thing. So I will put like this, up arrow, it will come, then we need to write loopback 1, so I will give loopback 1 here and put up arrow, it will come automatically, press this one. Here we configure the OSPF in our 4 interface. If you write here show IP route, you are not getting anything, because other router we did not configure the OSPF, only in this router we configure. If we write show IP OSPF neighbor, we don't have any neighbor. Why? Because only this guy is only having the OSPF configuration. If we write show IP protocol, we can see here what we are getting, OSPF1. and automatically if you see router ID, this guy is selected. If you see show IP protocol, we will type, and if you see here what we are getting, router ID. Router ID is 2.2.2. Okay, router ID is 2.2.2. How it is 2.2.2? If you remember what we told, it will check the first logical interface, loopback. If we have more than one loopback, he will check which one is having the highest IP. This one is having the 1.1.1, this one is 2.2.2. That's why this IP is selected as a router ID here. If we don't have this one, then this one become as a router ID. If we don't have this one, then from this and this they will select which one is the router ID. They will select this one as the router ID. Okay, anyhow, let me copy paste the configuration so we can verify that one. So R1 configuration is done already. We finish R1 configuration. Now let me copy and paste the whole configuration in the R2. So I will copy all configuration and I will go inside the R2. So this is R2. Let me make this big and I will paste the configuration here. If you see all configuration, we already paste, no error, nothing, everything is good. If we have misconfiguration, we will get some error here. So no spelling mistake, nothing, everything is good here. And then we will copy this R3 configuration and we will paste in the R3 also. So I will go in the R3 console. This is a R3 and I will paste the configuration here. Okay, so R3 is also having. Now we need to verify in the R2. We are doing the loopback router ID lab. So now we need to verify in the R1. So I will go in the R1 and let me make this big. And here we will write, we have the neighborship here. We have the state from loading to full. OSPF is having the 7 state. In the coming classes we are going to discuss that one. Now just remember here they have 7 state. Whenever they want to form a neighborship with the router directly connected to him, they need to pass through 7 state. We have down state, init, two-way. We are going to discuss that in detail later. Now just I am saying that one, they finish that all state and they are become the adjacent. They form the neighborship. So anyhow, let me show you now. It will come the root. Before we don't have the root, now we will have the root. So this is R1. Still we did not get. We wrote here show IP root, show IP root. Still it is not showing us the O. We should get something about O. If we are learning something from O, it should be appear here. Okay, so what we will check here, because we don't have anything here directly connected we have here. If you see, this is a directly connected network, this is also directly connected network. That's why we are not learning anything with O. If we have any loopback here, then we will learn that one, or any link, any network here, and we keep in the OSPF. Okay, so OSPF is working. Or if you have any confusion, what I will do in R3, I will create interface loopback 0. Okay, and I will write IP address. We will give IP as a 3.3.3.3 255.0.0.0, and we will enable the OSPF in this one also. So what I will do, I will go here, I will paste here, and here I will write the first. I will keep this interface here, and then in this one, let me delete this from here. I will copy and paste this one more time here, and here I will write this one as a loopback 0. Okay, loopback 0. So what I done, just I created one interface that is a loopback 0 in the R3. Okay, now I want to activate the OSPF in this loopback. So how we can activate this command, but we need to go inside the OSPF first. So let me, this command should come here above here, and this will come here. Okay, like this. So we need to write here router OSPF router OSPF 1, and then interface loopback 0, and then we will write IP OSPF 1 area 0. So now we created one loopback. Let me write here. Here we have the loopback 0 and we give the IP 3.3.3. So this route we are going to learn now. Okay, this route will show you here and here all in that route. Even if we did not create, no problem, we need to check only the router ID, but I want to show you the other thing also, that's why I configure that one. So now I will go in the R1. If you see R1, we did not learn any route from the OSPF, but now we have the route, so we will have the route in the routing table. If you see, we are learning the one route with the O. Okay, it is coming as a O. If you are getting difficulty to read this all, we have one more method. What we can do, we can write show IP route, then OSPF and press enter. It will show you only the route which is learned from the OSPF. So if you see here, what route we learn from the OSPF, this one only, 3.3.3. AD value is 110. As we told in our previous class, AD is nothing but administrative distance, and OSPF is having the 110 as a AD value. Okay, and if you see, this is a metric, this is a OSPF metric. OSPF metric is nothing but cos. In our starting class, first class of OSPF, we told OSPF metric is cos, and we are going to check how cos will be calculated, how we will get the cos also. So now just we are getting the cos as a 2, and if you see what we are getting, if anyone want to go to this network, they need to forward the traffic to this IP, and this IP, that is our leaving interface, is this one to forward that traffic. And this neighborship come up from how much time? This is only 47 seconds. But now if we check, this time will increase because now it take more time, because this will show when our neighborship, when we become the neighbor with that guy. If you see here, it is 47 seconds, here we have 1 minute 55 seconds. Okay, so what we are getting, we are learning one route and this AD value of that one, and this is a metric. And if anyone want to go to this one, they can go to this IP, and how we can leave the traffic to this interface, leaving interface. And from this much time we have this route in our routing table. That's all. This way we can check the routing table of the OSPF, as we discussed in our previous class also, this one. Now we are more focused on the router ID. So before going to router ID, we configure the OSPF in the R3, and R2 also we configure. So now we will check the router ID in the R1. So what I will do to check the router ID in the R1, we will write show IP protocol. When we write show IP protocol, we will get the router ID. If you see here, we are getting router ID here, router ID as 2.2.2. As we told, whenever we have the loopback will become as a router ID. So this is we have the router ID. What I can do, our theory is manually, if anyone done nothing, then loopback, if you have two loopback, which one is the highest, that will become as that one. So this loopback is the highest, 2.2.2, that's why it become high. If this one is not available, then he will check whatever loopback is available, that will become as a ID. So what I can do, I can make this interface as a DON. Okay, I can make this interface as a DON. So what I will do here, I will go to this interface. I will where is that interface? This is the interface loopback 1. Okay, so I will go here, config T, I will write interface loopback 1, and I will write shut. I make this interface DON. Okay, I make this interface DON in the R1. Neighborship will go down. Okay, neighborship will go down, and we will check here show IP route, show IP protocol. Still we have the same, we need to clear the OSPF process. How we will clear? We will write clear IP OSPF process, and we need to write yes, and it will clear, and then we can check. When we check, it will show you, we will have the new router ID. So let me write here show IP protocol. We can get the new router ID here. Let me check. Still it is showing because it will take some time. We need to reset in the all the router. Let me clear IP OSPF process. I will go here, I will do here also, and we need to wait some time, then we will have the new router ID. Directly we will have here, let me check here, show IP protocol. Now still it is showing the old one, but it will change. It should change because we put the interface loopback 1 as is down, right? Which interface we put down? Show IP interface brief. We put this one 2.2.2 as a down, right? So this should move and we will have the new one. We should have 1.1.1 in this place. It will come, but it is having maybe some issue in this one. We will check. It will take some time. Still it is sometime we have issue here in GNS also. It will change. It will change. This we already make. If we check show IP route, here 3 we are running. If you go here, show IP route, 1 minute, someone is calling me, let me. So now let's see router ID change or not. What we are doing, we will go in the R1. We are in the R1. Okay, let me show you the scenario. We are here and we will check show IP protocol. So here it is showing the router ID as a 2.2.2. Some issue may be in the GNS3. We need to restart the GNS3 so it will work. Let me save the configuration, okay, and we can reboot this router. But in the real scenario, when you clear the process, it will okay show clear IP OSPF process. This command we use to clear the OSPF process. Let's try one time. If it is not working, we will reboot the router. Okay, sometime we have the issue in the GNS3. We need to close the GNS3 and open the GNS3, then it will work. But anyhow, let's see. Let me write show IP protocol. Still it is having the same. It should change because that interface is already done. Show IP interface brief. If I go here, interface loopback 0, loopback 1, I will write no shut, and then I will write again shut, and let's see here show IP protocol. Some issue here. Let me reboot the router. Okay, some issue is here. Let me reload. Let me reload this router R1. We can do this lab in the packet tracer also. Sometime packet tracer is good to perform some labs there also. Anyhow, this is reloading and now we can check. Let me stop and start again, and let's see this console. Okay, this console is okay. Now we can check. So we already saved the configuration, so it will have the OSPF. Okay, we will see now. We will write show IP protocol. Now it is changed. Okay, see. But in the real scenario, just you need to clear the process, so you will have the different router ID. So what we done, we have the router ID 1.1.1. If you see here, we have show IP interface brief. If we write show IP interface brief, we have the loopback 0, loopback 1. So he is going to check the loopback first. This loopback is having 2.2.2, but it is down, so he will not consider this one. He will take this one. So now this is the router ID. Okay, this one is the router ID now. So now what I will do, I will make this one also down, loopback 0. So then it will check this two physical interface and he will take this one as a router ID. If I make this also down, then it will take this one as a router ID. So we will verify that one. I will write interface loopback 0 now, and I will write shut this one, and now we will clear the IP OSPF process, and then we will write yes, and we need to wait. it will reset the OSPF. And then we can check this one, we can write show IP protocol, but still same thing. So better we can reload the router, but in the real scenario no need to reload, just we need to clear the OSPF process. But here we need to close and open GNS3, so it will be okay, but better just I will restart the router, so it will make the changes. So this router is booting. Now we will have the different router ID. He will check the physical interface. From the physical interface, which one is having the higher router ID, that interface will have that interface IP will become as a router ID. So let me check now. I will write here show IP protocol. If you see here, this is the IP. This one is a router ID. Now we have the 200.1.1.1. Okay, let me show you show IP interface brief. So before first time we have this router ID, this one as a router ID, but when we shut down this one and clear the OSPF process, this IP become as a router ID. Again we put this is a shutdown and we restart the router, so this one become as a router ID. If I do same thing here, I will shut down this one and I will restart the router, then this will become as a router ID. Okay, so what we discuss in our theory, that same thing we have here. So let me do that one also. So interface fast Ethernet 1/0, fast Ethernet 1/0. I will shut down this interface and then we will save the configuration, do write. So we will have the configuration. Okay, now I can reboot the router. But in real scenario no need to reboot, just we need to write the clear IP OSPF process. So we will verify, so our router ID lab will be finished, this one. Let's see, it is booting up. Yes, let me write here show IP interface brief. So if you see, this interface is down here. Okay, and now after that we will write show IP protocol, and if you see, the router ID is changed. Okay, they taken this one. So as per theory we verify that one. Okay, as per our theory, whatever we discuss here, that we verify. And if you want to do manually, example, if you want to configure manually, we can configure manually also. Let me show you that also. First of all, let me make that all interfaces up. I will write interface loopback 0 no shut, and I will go interface loopback 1 no shut, and then I will go interface fast Ethernet, which interface fast Ethernet 1/0, and I will write no shut here. Okay, I make all interface up. Let me check show IP interface brief. So all interface is up, this one and this one. Now I need to do manual router ID I need to configure. So how we will do, we will go in the router OSPF1, and then we need to write router ID and whatever router ID you want to give. Manually you can give. Example, if I want to give manually as a 2.2.2.2, I will give this one as a 2.2.2. But when you see here, what warning we are getting, reload means restart your router or use the clear IP OSPF process command to take this changes effect. Means when we change any router ID manually, we need to reload the router or we need to run this clear IP OSPF process command. Then only these changes will affect. If we did not do clear or reload, it will not affect. Example, I change already the router ID, but if I want to check show IP protocol, and if you see, still it is not changed here. Okay, so what I will do, I will save the configuration and then I will say clear IP OSPF process, and we will write yes, and we need to wait some time, then it will change. But here if we have issue, then we need to reload. Anyhow, we will see that one. Okay, we will see show IP protocol. Yeah, see, now it is working fine. Now it is working fine. When I do the reset here, clear IP OSPF process, when I clear the OSPF process here, before what we have, before we have this 192.168.1.1, but now when we reset, it is coming 2.2.2. This one we configure manually. So how we will configure manually? I use this command. Which command I use to configure manually? This one. Okay, this command. First we need to go inside the router OSPF 1, and then we write router ID and whatever ID you want to give. I already write in the notes, so you can study here also. Router, go inside the router process, which one we are running, and then we will give the router ID. Okay, and we want to do the clear IP OSPF process, else it will not take. Okay, so we need to clear the process. We will clear by using this command. So this is a router ID lab, just basic lab to study the router ID, how router is taking the router ID.